Okay, sorry about that, that you had to switch to a second video. Okay, if we want to reflect over, I just don't like the way this is phrased. If we want a vertical reflection, so this is what we've always done, like we had a quadratic. If we had a quadratic that looked like that, opened up, when we reflect it vertically, it opens downwards. And that was our A value. So if we want to put that in here, for our square root, f of x equals, it would be negative square root of x. That would make it reflect vertically. If I want to reflect horizontally, so horizontally, it's going to be my b value. So it would be f of x equals negative square root of x. And we haven't seen one of these before. Well, let me just put one in the calculator so you can very quickly see. So if I had square root of negative x, let's take a look at that. So notice it goes to the left instead of to the right, the way the square root does. This is the shape of this is usually described as your eyebrow function. So just interesting tidbit. If I want to translate this horizontally, so move it right or left, that was our c value. So it would look like the square root of x minus c. So if I wanted to move 2 to the right, I would have square root of x minus 2. If I want to translate vertically, so up and down, I would have f of x equals square root of x plus the amount you want to move up or down. So when we put all the pieces together, we would get a times the square root of b parentheses, this is real important, parentheses, x minus c plus d. D is not under your square root sign, or radical sign. Okay, and notice that I have to have a single x inside this parentheses before I can know what c is. Okay, and likewise we've got the same thing going on with our cube root function. We'll have f of x equals a times the cubed root of x. That will give us our stretch or compression. If a is bigger than 1, we stretch vertically. If a is less than 1, we stretch, or we compress it. If we want to horizontally stretch or compress, we would have the cubed root of b times x. And again, this is the tricky one. If b was 4, that means that's a horizontal compression by 1/4, because it's 1 over b. Okay, if I want to reflect vertically, so if I had been opening up and want to reflect down, that's our a value. We just made it negative. So negative cubed root of x would cause it to reflect across your x-axis. If we want to reflect horizontally, which means you're going across the y-axis, we would have to have the cubed root of negative x. Translate horizontally, you can predict what this is going to be, cubed root of x minus c. Translate vertically, so up or down, and that's going to be the cubed root of x plus d. So we put these pieces all together. Our transformation function is a times the cubed root of b parentheses x minus c, close parentheses, then outside your radical symbol plus d. Okay, let's take a look at the back side of our notes. We're going to try some transformations here. Okay, you might want to plug these in the calculator. We want to sketch it, state the domain, range, and any intercepts, so x or y intercepts. So a negative is going to make it reflect vertically, and it's been translated by 2. So that means my starting point, instead of being at 0, 0, went down 2 points. And normally we would go over 1, up 1, but because it's been reflected, we go over 1, down 1, over 4 from your starting point, and down 2. And of course, you can be plugging these in the calculator if you wish. So my y-intercept is 0, negative 2. My domain, I haven't translated left or right, so it's 0 to infinity. And my range, ran out of room there. Let's see, I start at -2 and I get smaller, so I get more negative. So that means the lowest or the smallest value is going to be -infinity up to -2. So -2 is the largest y value I have on this curve. Okay, cubed root of x plus 3. The 3 is in the spot of the d, so that means it's moved up 3 and no other transformations. So I move up 3 and then draw this in. So on a cube root, we can go over 1, up 1, down 1 and to the left, and we can't really draw in any other points on this one. So it looks a little bit like that, and continuing both ends. Okay, so let's see, x-intercept. Do we have an x-intercept? Ooh, we might have to look in the calculator. So let's clear that. Math 4x, come out from under there, plus 3. And let's take a look at this. I'm trying to see when does it cross your x-axis. And it looks like we should go to our table because we don't just see it there. So as I scroll, notice my y values are getting smaller and smaller. Oh, look, there you go. So our x-intercept is at -27, 0. Y-intercept was at 0, 3. My domain, well, I continue going this direction and I continue. So domain is all real numbers. My range, again, I continue upwards and downwards, so my range is all real numbers. That's a nice, easy one to do. How about C? What family of function do we have? So this one is a square root we're looking at, so it's the eyebrow family. And I've got this -x minus 1. Okay, the trick on these, when we've got anything under the square root in front of x, we have to factor that out. So this is really the square root of -1 times, so -x divided by -1 is x. -1 divided by -1 is a positive 1. Okay, so we've got a negative, that is a horizontal reflection, and if I have x plus 1, that means my c value is -1. So I've gone over 1 to the left, and I've reflected. So 1, 1. So my starting point was at -1, 0, and we continued up. So x-intercept is at -1, 0. Y-intercept, there's none. We don't ever cross our y-axis. My domain, let's see, I can have very negative x values, and I can get up to -1, but I can't go past there. So it's from -infinity to -1. My range comes from 0 and gets higher, so I go from 0 to infinity. There we go. Okay, this one, we've got a value in A, so that's a vertical stretch, and I've got a negative, so a horizontal reflection. Let's put this in the calculator and take a look at this. So 2 times, cubed root of -x. And let's take a look at that. Okay, so it's gone down. It has not, our point is at 0, 0, but we've reflected, so this piece from here has gone to this side, piece from down here reflected over to here. And let's look at our table of values. Ooh, still in those very negative values. We want to take a look. Normally, if I went to the right by 1, I would go up by 1. But in this case, I've got a stretch by 2, and it's reflected. So if I go right 1, I go down by -2. Do we have any other points we can If I went over by 8, I should be at -4. Okay, and over 1, up 1. So this one looks something like that. You could probably make a smoother curve than I did. Okay, x and y intercept is the same point, it's 0, 0. Domain, cube roots, the domain is all real numbers. Our range is all real numbers. So we're all done with that guy. Okay, E, we need to factor that 3 out before we can figure out how it's been transformed. So 3 times x minus 1. So this means it's been horizontal compression by 1/3, and it's moved to the right by 1. That means my starting point is there. When I put this in the calculator, I do not have to put it in the factored form. Calculator knows what to do, so it's 3x minus 3. And let's graph that. So it's shifted over 1, and we can let's take a look at our table also. So 1, 0, 4, 3. Okay. So that's going to go something like that guy. And it continues in that direction. Okay. X-intercept is at 1, 0. Y-intercept, well, it stops right here. Or starts, you could say. So it never gets here. So there's not applicable. There is none. My domain. Let's see, the first x value I have was at x equal to 1, and then we have all sorts. So 1 to infinity. Range goes from 0 up to infinity. Okay. Okay, so F, we've got a negative out in front, so that's a vertical reflection, and a 4 is going to be a horizontal compression by 1/4. So let's plug this in our calculators. Negative cube root of 4x. And when we look at this, it hasn't shifted up or down, so it still goes through 0, 0. And let's see what our tables look like. So negative 2, 2, 0, 0, 2, oops, 2 positive 2. I wasn't reflecting that, that's not good. And then positive 2, negative 2. And we just draw this in at this point. That will be our cube root function that has been transformed.